Good afternoon, guys, or good morning. So I want to show y'all a couple things here that we're going to be working on with the metric system. I think y'all are familiar with something like this. There's the camera. You ever have to text or call that friend of yours and say, hey, bring some more Sprite. Hey, bring another jug of milk. Do you tell them to get a gallon of Sprite or do you tell them to get a 2 liter of milk? Sell Coke in 12 ounces. Hey, when you have to store, pick up 67.6 fluid ounces of Sprite, please. I think you crazy. I think you crazy. What the 67? What? Because we call it a 2 liter. So that you know this is a 2 liter already says you're familiar with the metric system, which is the point of this lesson, the metric system. We don't use a very consistent system because what do you call this? A gallon. Or do you say pick up 3.78 liters? So there's all these ways of measurement. It's nice to deal in solid numbers like 10s and 20s, 12s. Now, because of our come and go gas stations or whatever you have, Casey's, Signal, you name it, you know, we know what 12, 20, 32, 44, give me the 64 ounces, please. We know what those ounces are. And when you ask for that 44 ounce or 64 ounce, you're looking at about this much. This is 2 liters. 1 gallon is almost 4 liters. All right, so this is about double this, right? But not quite, because it tells me it's 3.78 right there. And you can look on your own. Sorry, didn't mean to advertise for great value. Anyway, you get the idea. Or should we just go ahead and say, I want 355 ml of soda? Because if you bought a bottle of water, and you probably have, you know that that bottle of water was either 1 liter or half a liter. Sometimes they sell the 20 ounce or the 7.5, meaning a 750 ounce. So we're going to go through not completely what the metric system is and the power of it, but I want you to begin thinking about metrics in terms that you're familiar with: meters, centimeters, and liters, and grams. And I know you know the only thing that's measured, or things you've used in measuring grams: sugar, right? So we're going to, I'm going to just walk through some examples for you and go over the worksheet that I posted for today. Okay, so under classwork, you'll see week 1, scientific method and measurement. This is going to be Wednesday's 2nd hour lesson, metric system. All right, so you click on that. I would advise before you do this worksheet or anything else that you do at least watch the first 7 minutes of this video. This gives you a little bit of the history and the background, just kind of gets your mind thinking as to why we're even doing this. If the jug of milk and Sprite didn't do the trick for you. Anyone who's worked on cars also knows that oftentimes you'll have a wrench that's of the metric units, and then you'll also need a bolt or a socket that may be 5/8, you know, and it's in the American system. And so you have to have 2 toolkits to work on these cars that we saw in America. How easy it would be if we just needed 1 toolkit, right, that could measure and do all the work in the metric system. And trust me, the numbers are much, much easier. The confusing part of all of it is that it's the units, what we call the units, inches versus, say, centimeters or millimeters and the like. Okay, so that's the biggest thing. And I'm going to do a couple examples. I'm going to give you an illustration over here shortly, but I just want to show you where to get the lesson. So you click on that, and you'll have the instructions as a reminder to open up. But I'm going to work from this sheet right here. Okay, so there is math, and there are some conversions you can use that are taught, and in time, hopefully, if you continued your studies or you went to college in science, they show you how to do how to use the conversion systems, where really what you're doing is you're doing division. So you would do 1 fraction times another fraction in order to get your units. But at this point, I don't want to confuse, and there are some cheat ways, some cheap drawings to do this, okay? And we're going to do that right now. So first, let me go ahead and tell you what the units of measurement are. So you can see over here on the left-hand side, there is, make sure I'm recording, yes I am. This is your basic unit right here. I'm starting right here in the middle. Your liter, meter, and gram, okay? Again, liter, meter, and gram. So liter is for volume, okay? Meter is for length, gram is for weight. So then all these other three, you can either be smaller than a liter, smaller than a meter, smaller than a gram, or you can be bigger. So if you're bigger, all right, you're on this side of the stairs going up. If you're smaller than a liter, meter, or gram, then you'd be a unit of measurement that's over here. So these are your units of measurement. And the basic unit is kind of your beginning for all of this, all right? So to give you a quick illustration, some ones that we're familiar with. We are familiar with centimeter, abbreviated as cm, and we're often familiar with kilo. And if it's meter, it's kilometer or kilometer. So these are the abbreviations, as you'll see in one of the videos, km and cm. And then this would just be plain meter, liter, or gram, which is only L, M, or G. Okay, so let's come over here to the right side real quick. And, oops. Let's come over to the right side. So let's say we want to know the distance between from here to here, right? We wanted to know from this point to this point, okay? And I told you then that it is 1 meter. But I don't want to know in meters, I want to know in centimeters. So how do I convert to a centimeter? Well, centimeters, it looks like, are 2 spaces away from the basic unit. So I'm going to tell you that this whole system is based on the power of 10, 10x. And that's part of the beauty of the metric system, is that all you're going to do is be moving the decimal over. And to show you what I mean by moving the decimal over, we're going to use this 1 meter right here. Okay, so each of these dashed lines, 1, 2, 3, 4, so forth, all the way over, if you count them and take the time to pause the video, you'll see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 centimeters up to this point right here. We count another 9 centimeters, and how we have 20 centimeters right here. And if we continue all the way to this meter, what you're going to find is 90 centimeters and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more. And you're going to have 100 centimeters. 100 centimeters in 1 meter. So 1 meter is equal to 100 centimeters. You can see this on a meter stick like we have in the classroom that I don't have right now. So you would say that there are 100 of these little dashed lines inside of just 1 meter. But notice the number of 1 didn't change. The number of 1 didn't change. What changed is the number of zeros. Now, why is this number bigger? Why is there a bigger number of centimeters? That's because the centimeter itself is much smaller. So because a centimeter is a smaller unit, remember over here, unit? Because centimeter is a smaller unit, it takes more of them to satisfy what 1 meter is. And 1 meter is much larger unit. Remember our greater than, less than over here? So a centimeter, whoops, that backwards. We can make mistakes, right? So these are chihuahuas. Got what I want you to do. These are much bigger than those. There we go. So a meter is much bigger than a centimeter. Centimeter is smaller. Just like the meter is smaller than the kilometer. So that's why we use the stairway going up and down. This shows the largest, and this one shows the smallest unit over here, largest unit over here. I don't know if that makes sense. I'm just trying to show you as much as I can to make the point clear. So 100 of these little units make up one of these units. And guess what? It would take 1,000 of these units, meters, to equal just one of those kilometers. Okay? So even those 100 centimeters here, if we did 1,000 of these meters, then you're going to get what is called 1 kilometer. So that's what the video, and that's what this is trying to show you. This little lecture is not meant to make that clear, but I wanted you to see this visual, as cheap as it is, of how units are the big deal here. Okay, so I'm going to come over, I'm going to clear this, and what I'm going to do is just go through a couple problems here. So let's use this cheat here, and I filled in each space on the smaller units to the right and the larger units to the left. Okay, so you have deci, centi, milli. So given our example a while ago, 1 meter, we now know it has 100 centimeters because centimeters is a much smaller unit. So to demonstrate how to use this ladder, and there's some instructions written in these boxes. So to convert to a smaller unit, as we did, you're going to move the decimal point to the right or multiply. So if we had 1 meter and I wanted to know how many centimeters, well, I simply went 1, 2. I had to jump 2 spaces over. So I write my 1 because the math doesn't change. But I do have to go 1, 2 over with the decimal point. So 1, 2, and I fill in the zeros, and that gives me 100. But 100 what? Centimeters. So cm would become the abbreviation. So 1 meter equals 100 centimeters. If you're converting to a larger unit, okay, move the decimal point to the left or divide. So if I knew, going based on the power of 10, all right, that this was 10 times, then to go from meters to deci, I just do 1 times 10, and that is 10. So I know that 1 meter is equal to 10 decimeters. 1, 2, that is times 10 times 10 again. So 1 times 10 times 10 equals what? Well, 1 times 10 is 10, and 10 times 10 is 100. And I would be at the centi, 100 centimeters. All right, so there's a number of ways to do this. You can, bottom line is you're just going to move the decimal. If you don't get the power of 10 concept that I'm kind of sharing right now, then just remember that all you really have to do is jump spaces. So I'm going to show you this here real quick. Oh, I cleared my, hopefully you have them. Again, it was deci, centi, milli, deca, hecto, and kilo. You might think King Henry drank dark chocolate milk. Some people remember that, but might be best just remember kilo, hecto, deca, so forth. All right, but I want to do an example, so let's try these conversions using the ladder method. If you'd like, right now is a good time to pause this video and work out at least maybe these two right here. Okay, if you're turning it back on, so we have 1,000 milligrams, so I'm going to write 1,000 mg. So first, where am I at? I'm going to be over here. This is the m. Remember, the base unit kind of doesn't matter. It just tells you whether it's weight, liquid, or measuring a length, but we are interested in the prefix. That's the unit. So we're at milli in this problem, and we want grams. So to get from milli to grams, what are we going to have to do? We need to go back. Again, we can divide by 10 times 10 to 1,000, or we can simply count the jumps in decimal places. 1, 2, 3. So the answer here in grams, if I count the decimals from here, 1, 2, 3, then I know it's 1 gram. So the answer here would be 1. Okay, so 1,000 milligrams is the same as 1 gram. Let's do one more in the opposite direction. So we have 1 liter equals how many milliliters? Again, the number won't have to change. You're still up from 1. And we're at the basic unit. A liter is the basic unit, often capitalized. And you want a milliliter. Again, that's way over here. So to get there, we're going to have to go 1, 2, 3. And so when you go from 1 liter and you want to know how many meters that is, milliliters that is, you write your 1, and we're going to go 1, 2, 3, 1, 2, 3. And you put that decimal there. So here you're going to write 1, 0, 0, 0. Okay, and you put that comma there. So 1 liter is 1,000 ml. So how many milliliters are in 2-liter bottle of Sprite? How many milliliters? If you know 1 liter has 1,000 ml, how many ml are in a 2-liter bottle of water, Sprite? 2,000 ml, right? So you can do the math pretty easy. The numbers don't change. What changes is simply the units. All right. So pause it and do one more, and then I'll do my last one, and we'll be done. I've written the steps on the worksheet, by the way, in the top one that you find. So it'll remind you how to move to the left and move to the right, and I have an example done out there for you. So if you have 160 cm, where are you going to start? You're starting right here at centimeters. I'm going to go ahead and clear everything. So make this. So we're starting at cm, and I remember that cm was right there. And we want to go to mm, which is right next door. Hey, neighbor. Millimeter. So we're only going to have to jump one time to the right. Notice it's to the right. We're going to a smaller unit. So 160, 160. The mass shouldn't change in any of these, but going from centimeters to millimeters is one jump. So it means we're going to have to add an extra 0 and then put the decimal point there. And that would be the answer for this one. You'd probably be able to type it in better. So if you want to use the typer on the Cami, you can just put in the text box, or you can use the draw and write it as bad as I did here. All right, so 1,600 millimeters are in 160. Again, notice that in each of these cases, the numbers didn't change. All that changed was the unit size. Okay, I hope that helps, and thanks for watching.